So Stuart Minchin, I'm the Director General of SPC, the Pacific Community, as has been mentioned already. And I'm going to talk to you about an initiative that really arose from that geo plenary and ministerial meeting in Canberra that was mentioned earlier by Craig and Emma. And really, it's an example regionally of how geo can actually help the region, because what we're doing with Digital Earth Pacific is actually learning from activities that have already gone on under the banner of geo in Australia and in Africa. So let me take you through a little journey on what Digital Earth Pacific is and how it's come to be where it is today. So first up, I want to talk about why we're doing this. What's the reason for developing a service like Digital Earth Pacific? And it really comes down to this slide. This was a report that was released at the Geo Plenary in 2019 that highlighted the economic value that countries in the APEC region, APEC countries, get from Earth observations. And it highlighted that today, the current value per year of Earth observations, Earth and marine observations to the APEC economies is in the order of $372 billion US. But that's expected by 2030 to grow to 1.35 trillion US dollars, right? So that's a huge growth area. And how can the Pacific benefit from this growth and actually make use of economic activity in this area is the real question. So we're doing this not just to be nice, to manage our environment, but for genuine economic development purposes. Okay, Earth observations. We've been monitoring the Earth from satellites for over 40 years. We've been capturing photographs from space of how the Earth is changing. But in our region, we haven't been making great use of this information. And that's because to turn a satellite image from a photograph from space into actionable information is very challenging. It takes a lot of calibration, orthorectification, a lot of science to turn it into data that you can actually compare. And then even if you've got the data, to turn that data into actually useful information is a real challenge, right? And in the Earth observation community, for many years, we were delivering data, we were delivering images, but we weren't turning it into actionable information. And so in Australia, we developed a tool called Digital Earth Australia that was actually an attempt to automate this process. So what Digital Earth Australia does is turns those raw satellite observations from space, transforms it into what we call analysis-ready data. This is calibrated, orthorectified, atmospherically corrected data derived from those satellite images. We then transform that into decision-ready products that people can make use of to make decisions about their environment. Sorry, I'll go back. And if I could use an analogy to explain what I mean by decision-ready products, here on my phone, I have the weather report for Noumea today, where I am. That weather report is pretty simple. It's got clouds. It tells me it's going to be 23 degrees today and there might be a little bit of rain, okay? It doesn't require me to download data about the atmospheric moisture or content or the wind speed at 1,000 meters. All of that data is feeding that weather report, but it's happening in the background. And what they're delivering to me is the useful information that does not require me to become a meteorologist to make use of. That is what I mean by a decision-ready product. And what we've been doing with Earth observations for many years is delivering data to people and wondering why they don't use it. Because to use it, they've got to become experts. And we need to be providing data in ways that people can actually make decisions without having to learn Earth observation or remote sensing in the background. So decision-ready products is what Digital Earth Australia was about doing, setting up a service, a bit like a weather service, to deliver regular, routine products that people could make decisions on. So I'm going to show you a couple of those products coming out of Australia. So here's one. What this is a picture of the water quality in this lake in the centre of Canberra. Oops, sorry, I'll go back. Okay, it's all right. I'll on the back, is it? Okay. So, apologies. Okay, so this is Lake Burley Griffin in the centre of Canberra. We have a transect running through the lake from the top end of the lake down to the bottom end of the lake. Top end of the lake is on the right-hand side of the graph, the bottom end of the lake on the left-hand side, and this is years going down this axis. So what you can see is in the 1980s and 90s, very poor water quality all the way down the length of the lake, and then in around 2000, much cleaner water in the lake. And this is because there was a policy change, there was a cleaning up of inputs into that lake, and you can see the impact from space on the water quality of the lake. But importantly, you can do this for every single water body on the continent of Australia. And every time a satellite passes over, you add a new data point and you can actually measure what the lake's water quality is on an ongoing monitoring basis. So this is one example of a decision-ready product. You don't need to know what all the science that's in behind it. You're just being told how healthy the lake is. This is an agriculture example. So what we're looking at here in this little black field is what this graph is showing over time. And what we're seeing here is in green is photosynthetic or green vegetation. In orange, it's dry vegetation, and in red, it's bare soil. And what you're seeing here is the pattern of this field where a crop is planted, it greens up, it dries off, it gets harvested, and then the next year there's another crop, and then the next year there's another crop. This was a wheat field that was being farmed for wheat, and you can see that some years are more vigorous than others, so different yields. And then in 2004, there's a change, and this pattern changes, and that's because they changed that crop from wheat to almonds, so it became a tree crop effectively, and you can see the growth of the biomass of those trees. So this is the history for 30 years of the productivity of that field, and you can do that for every field on that farm. You can do it for every farm on the continent. You can basically have this information for every 30 metre square of Australia. Right, so this tells you, and it's a monitoring capability as well. You can take today's satellite overpass and use the historical data to predict yields for this season. Coastal change and erosion. This is 30 years of erosion on this end of this island, and deposition you can see happening here, and the patterns of the movement of the sand over time. This is not just pictures though, right? Every step along this pathway is data, and you can actually extract from that really useful information on change in bathymetry and coastal erosion around all of Australia. This is mangroves. You can see the mangroves over time growing up this area. And if you look, when it hits 2014, you'll see a dieback event. There we go. So the mangroves all died in this area, and only the very fringing edge of the mangroves is still alive. We can track every mangrove across the entire continent of Australia and show you the impact of every cyclone that comes through and how the mangroves recover, what the dieback events that are happening and how things change. So these are some examples of decision-ready products. I'll move on from that. So Digital Earth Australia is a platform for turning satellite observations into decision-ready products. Now, in Australia, we recognise that we developed something really useful here. So through GEO, we made this available as an open source tool to be made available globally so that other countries could benefit from this technology. And in fact, that's happened very actively. So the Open Data Cube code, which we used to develop this tool, is now being taken up right around the world. You can see all of these different implementations happening globally. So very active implementations in Mexico, in Colombia, in Brazil, a lot of activity in Africa, which has led to a similar project to Digital Earth Australia, where we've done the same for every African country. So Digital Earth Africa is replicating the capability that we did for Australia and has developed that same capability for all of Africa. Every one of the 54 countries of Africa now has access to this sort of information. I'm just going to show you one slide. This was a report released at the beginning of this year by the World Economic Forum that looked at Digital Earth Africa for just 3 sectors, looking at earth observation industry, agricultural productivity and illegal gold mining, and identified that Digital Earth Africa, just in those 3 economic areas, had an annual impact of $2.3 billion per year to African economies. $2.3 billion for what is a $7 million per year investment in creating that, that capability, right? So a small investment in setting up the delivery and transformation of this data from satellites into actionable information can have a huge impact on economies, right? And what we want to do in our region is actually benefit from that. So Digital Earth Pacific is an attempt to bring this same technology that has been proven to work across the entire continent of Australia, across the entire continent of Africa, and bring it into our blue continent of the Pacific and make use of it in our region. We think it will be useful for a whole range of big issues in our region: climate change impacts, coral bleaching, maritime surveillance, water quality, agriculture, water, vegetation. And so we kicked off this program to initially work through what was possible with this technology and what was a priority with the countries. So Digital Earth Pacific Phase 1 has been underway already. The process was about developing the needs assessment to work with a number of countries in our region to identify some prototype infrastructure so that we could show that this actually worked in our region, and to build up the business case and raise funding for this service to be provided free and open to every country in our region. So that's what Phase 1 is about. It's been underway now since the beginning of the year. It kicked off in March. We're now in November, and we're getting to the point where we've actually, we're hoping later this month to release the prototype version of Digital Earth Pacific, so that some of these products will be available to countries in our region. There's been an extensive consultation underway with many of the countries in the region about what their priorities are, and I'll just share with you the highest priority use cases that have been identified. So these Tier 1 use cases are the things that every single country we talked to said was a priority for them. They need agriculture, vegetation tracking, coastal change detection, forest cover change detection, cyclone impacts, particularly on mangroves, inundation modelling and flooding, updated digital elevation models, and land use and land cover mapping, right? So this was consistent to all the countries said these were priorities. The Tier 2 cases were where a number of countries said they were a priority, but not every one, and or something that needs a bit more research or development in order to be operational. And you can see the list there. There's a whole range, some of them very, very specific, but most of them tractable to this technology in an operational sense. So ultimately, Digital Earth Pacific is aimed at developing an operational infrastructure, something that people can rely on, just the way that we can rely on the daily weather report. Anywhere in the region, you can get access to the daily weather report. When Digital Earth Pacific is operational, anywhere in the region, you'll get access to these decision-ready products. They will be updated every time a satellite flies overhead, and you'll have new capabilities to monitor change and impacts of disasters in our region. So thank you very much.
Thank you. Thank you so much, Stuart, for this presentation. Do we have any question from the audience, both physically and virtually? Maybe I might have one, actually, or even two. The first one will be, we face something, even in New Caledonia, that our users are not experts. You said that, and this is really important to take into account. But they have to be able to rely perfectly on the services that are delivered to them. And if they are not able to challenge the services, I mean, the veracity of the given information or everything, it can become the problem. So how do we make sure that all the services and information that are provided are true information they can rely on to make good decisions?
Yeah, thanks. That's a great question. So first up, it's important to recognise that that these products are not ever going to be perfect, right? So they have limitations, both in scale and in precision. So they're not always a perfect replacement for an in situ measurement, for example. However, they give consistency across all spatial areas, and an important part of this is that we co-design these products with the countries themselves to meet their needs. Every product that's been developed, for example, in Digital Earth Australia, has also been published in the peer-reviewed literature, so that it's open, transparent, how that product is generated, the strengths and weaknesses of that product, and it's all shared openly as an algorithm with the global scientific community, so it can be absolutely transparent what its positives and negatives are. I don't want to oversell with the resolution of satellite data we've got available. For example, you're not going to be able to measure with the same precision water quality, for example, that you would do by going and dipping a bottle in a water and taking it to a laboratory. However, you can measure every water body in the country with very little cost, whereas going and dipping a bottle in the water and doing that precise measurement, you can only afford to do that for one or two water bodies. So you're weighing up measuring very precisely in one or two locations, or measuring everywhere less precisely. Which one gives you more accuracy is the question. So, and I'd argue it's the latter.
And actually, here comes my second question. So you got, I think, through these kind of initiatives and platform, a key role of, how you say that, trusted advisor or trusted service provider. Here I come with my hat as Insight Director. We would be glad to participate to such initiatives. And this could be also really great for us. Then we have kind of recognition of what we deliver as a service provider, as a private entity. And my second question will be, from the moment you can give to all your users a guarantee of the quality of the services provided, how can we, as private sector, help you in developing all those algorithms and actually ready-to-use services, since this is already what we try to do locally?
So that's a great question. How does the private sector fit in? So the intent here is to develop consistent and common services that are regional public goods. But the real benefit to that is that then the private sector can add value to those regional public goods. So a great example in Australia, there was, with Digital Earth Australia, there was an active campaign to work with private industry to work out how they could value add to those products. And a great example, that agriculture example that I showed you, there's a company in Queensland called SIBO Labs that took that base product of that agriculture example and transformed that using their own machine learning algorithms into a measure of the amount of grass growing in every field. And from that, they turn that into a service for every cattle farmer in the country, so that they could actually map their own farm and identify which fields had food for the cattle, and they could move the cattle into their fields. And they get that on their mobile phone from that company. So the company is relying on the underpinning data coming from Digital Earth Australia in that case, but they're adding value to it, and that service is provided to 80,000 cattle farmers in Australia to make them more efficient at their managing their farms. So these are good examples where the private sector can really rely on the underpinning infrastructure, but at the same time add real value to specific sectors and make economic benefit out of making use of that. So that's what we want to encourage in this region, is smart entrepreneurs that want to take it to the next level to utilise the baseline. They then don't have to do all the hard work of transforming the satellite images into, and doing all the science and the cleanup behind that. That's already done by the service, and they can concentrate on the value add component to sell to their customers.
So Pearl Winchester, and I just had one. It's actually two questions in one. You said you delivered the Open Data Cube, and actually thanks for that. My first question is, did you have any obstacles? Did you meet any obstacles or people that were against the open data thing, and how did you overcome it?
Yeah, that's a really good question in our and one that's active in our region. There are always people concerned about what the implications of sharing data is. In Earth observations, that we did have concerns from people about privacy. Was this going to be used against our farmers, for example, in tracking their activity? In fact, when we were trying to get this service up in Australia, it was our agriculture minister who, at the time, who objected because he thought it was going to be used to track farmers, right? And we said to him, actually, most of the farmers are doing the right thing. And at the moment, large-scale farming conglomerates, the Monsantos and the big companies, already have access to this information, but the mum and dad farmer don't have access to this because it's too complex to develop. So by providing this service, you're levelling the playing field and you're giving them access to information that the big companies already have. And that helped explain the benefits to this. And it was only 12 months later that the agriculture minister stood out on the steps of Parliament in Australia and said what a wonderful service this was to farmers. So it's possible to talk people through. There are real concerns that people have with sharing data, but there are answers to that, and there are examples where often the fears in sharing data are unfounded. And when you actually explain how it's worked for other people, people start to recognise that actually the benefits from sharing data are much greater than the negatives. So it's education.
Two questions.
Stuart, peut-être une question moins technique, mais tu indiques que vous êtes dans une phase de développement, en tout cas de premier niveau de discussion avec le Pacifique sur le déploiement de Digital Earth Pacific. Première question, tu l'as peut-être dit, mais avec quels États du Pacifique insulaire vous travaillez sur cette première phase, et comment entendez-vous élargir et notamment associer les territoires francophones du Pacifique à cette démarche?
Yep, thanks very much, Anne. So the 4 countries we used 4 pilot countries for this first phase. The Marshall Islands, Vanuatu, Fiji and Tonga. We wanted to cover the sub-regions in the area. The next phase of the project, so we've already got consistent use cases across the program. The next phase is really to find the donor funding to support this. Now, we were able to do that for Africa. In Africa, I approached a philanthropic trust who came up with half of the resources to do this for Africa, and then we were able to get matching funding from the Australian government for Digital Earth Africa. So that was able to be funded. It was in the order of 25 million Australian dollars to develop that. So our next step is to get funding to actually create this for the region. Obviously, with our French-speaking territories, it's going to be important that, and this link here is a really important one for us, because working with Jean and others in the region to develop the French connection, if you like, to this work is really important. The interfaces have to be multilingual to support that as well. So we're very aware of that. We're very keen to engage with this community, and for this community to be involved in developing their own value adds to Digital Earth Pacific. So this is not something that we're going to lock behind a gate. The intent will be there will be sandboxes for people to develop their own products to make use of these routine things. Digital Earth Pacific will provide a regular flow of this analysis-ready data. And we'll transform that into certain products that we know people want, but there's a huge opportunity for people to add their own, to develop their own products or to innovate based on the products that we're already delivering. And working with the other countries, they'll have specific needs that might not be common to every other country in the Pacific, and there's always opportunity to develop, further programs of work around this. But we really need a core funder at this point to get this up and running, and we're actively working on developing the resources to tackle that. I'm very confident we will, because Africa, it really only took a dinner with a philanthropic group, and we had half the funding. So this is very low cost, very big impact stuff that's very attractive to many global donors.
Bonjour, bravo pour ce programme. Donc il est surtout orienté sur l'agriculture, et on peut le comprendre avec l'Australie qui est vraiment une île continent, et donc une agriculture qui est un domaine phare chez vous. C'est probablement moins vrai dans les pays du Pacifique, qui ont plus une agriculture de subsistance, et probablement d'ailleurs des exploitations qui ont une taille telle qu'elle n'est peut-être pas au pas de résolution que vous suivez. Mais ma question porte davantage sur ce qui préoccupe les pays du Pacifique autour de la mer, c'est-à-dire la ressource halieutique, à la fois la connaissance et peut-être la surveillance, l'évolution. Est-ce que vous avez dans votre programme déjà des objectifs ou des projets dans ce domaine-là ?
Yes. So first up, the agriculture issue, I showed some examples from Australia, and yes, you're right, extensive agriculture in Australia. We are working and have been working with countries in this region, though, on looking, for example, at detecting disease in coconut palms in Vanuatu, for example. We're looking at kava plantations. We can measure the sugar crops in Fiji. So it's not completely, pointless in that area. There's no doubt in our region the coastal and maritime products are going to be much more important. We have already work on substrate and water quality measurement from these imagery that's been developed in Australia that can be directly transferred. Coral bleaching, for example. We have examples that have been developed around identification of fishing vessels. So you can pick up things, particularly with the radar based data. You can actually pick up vessel tracks, for example, remotely. So those kind of products we're very interested in developing in the region. They currently sit mainly in the tier 2 products at this point in time, only because not all countries agree that they're the highest priority at this point in time. But we absolutely intend to continue to develop the marine products, and we have partners that are working on this actively in Australia and overseas to work out how these products can be developed in the region. We're collaborating with NASA on this as well. So we've got a partner in NASA who's working on some of these prototype products as well.
Thank you. Thank you for that. This is always the problem we face with such interesting presentations, is that we got too many questions after. We had 2 questions online. I think you answer the first one even partially from about maritime surveillance from Sebastian Insight. I think we'll be able to connect you and to give more information about the specific services, even to the National Navy. I did not see the question from Flora, CSIRO. Could you take something like 2 minutes to answer?
Yeah.
Thanks.
I'll be very quick. Flora just asked about radar. I just mentioned radar. So absolutely, we intend to include radar in Digital Earth Pacific. One of the challenges we have in our region is the coverage of data. So radar, there is global radar coverage available, for example, through Sentinel-1, which is a European satellite. The problem is it gets turned off over our region because the land areas are too small, so they save the battery by turning off the radar. So the capture regularity is much less regular than it could be. We are actively working through GEO to influence the acquisition strategies of the space agencies to try and get them to turn on their sensors when they're going over our region, because it could be so valuable for us, particularly with cloud cover in our region. Often the optical satellite is challenging because of cloud cover over the islands themselves. So having regular overpass of radar where we can see through the clouds is really critical. So any contacts that you have in the space agencies, please advocate for them capturing data over our region, because it's something they can do relatively cheaply in the grand scheme of things that can have a huge impact for the Pacific if they capture more data in their overpasses from our region. So thanks.